Good afternoon, everybody. So, hopefully, by this class and next class, I will complete my schedule topics, and then after that, we will review. So, whatever questions you do have, sometime last time you brought a question, right? Are you able to solve that one? Okay. I will discuss, but after the class, you can please see me. Okay, I will show you some, or I will also discuss in public in next week or next class. Okay, so let us look at our schedule. So according to our schedule, we are at the end, almost at the end. So in today's class and maybe tomorrow in next class, we will discuss binary search tree, and that will be our last topic, and after that we will review. Okay. What is this? Okay, hopefully from today's class and from next class you will get 10 points. I like everybody to get these 10 points. But if you give attention, then you will get this 10 points correctly. But if you do not give attention, then you will lose something. Okay, it's up to you. 10%, yes. You will get 10% from today's class, hopefully. And it will be easy if you give attention. No, for final. For the final. Okay, and after the second half, maybe I will finish this in 30 minutes. And after the second half, I will discuss about something that you appealed for your test regrading request. Some of the topics maybe I will discuss with you that the common mistakes some of you did, but still you are arguing that okay, this is a very simple. For instance, okay, so but if you in the second half, if you were interested to know about this you can stay here or you can leave after 30 minutes. Okay, but for instance, there is this common mistake that many of you or some of you did not check the null pointer. Null check, you did not check the empty situation for a stack, for a push or pop operation. So we decided we deducted some points, but because that was a major part, but still if you argued that okay, I did not do that, but still my program is working, but it is okay. For instance, let me give you a very common example. Okay, if I am about to sit on this chair, okay, you understand? If I am about to sit on this chair, okay, I know that this chair is available here, so I am sitting here, okay, so blindly. So if someone moves the chair, removes the chair from here, what will happen? Who will fall? Me. Okay, that means I need to check first whether my chair is available there, right? Right? So that is the empty check. So in a stack, you are going to push something or you are going to pop something, but that is not available. So that means that will make an error. So think about that situation. You did not check that empty situation, right? So it is required to check. Okay, I will discuss this. I will show this in real program. In live program, what happens if I do not check the null pointer? Okay. So, but that will be in our last section, in last 20 minutes maybe. But for the first 30 minutes, let us discuss our last topic, binary search tree. We will be discussing binary search tree, but in the lecture module, okay, you will see that is as a non-linear data structure. Okay, the topic is under non-linear data structure. Am I recording my stuff? Yes. So far we discussed mostly linear data structures. So our linear data structure started from a list of or an array. We know an array, right? An array contains a group or a set of similar or same kind data, right? Then I discussed dynamic linked list. One is the built-in linked list, that is called array list. Array list, array list. I discussed array list, right? And then we discussed linked list. Those are dynamics array. So one of the advantage of array list is that you can grow your array while you run your program as needed. But one of the main limitations of array is that you cannot grow it while your program is running, right? In many situations, you have to keep your program running for a while or for a long time. For instance, think about the operating system. While your computer is running on an operating system, can you change anything in the operating system? No, right? Because your program is running, operating system is running, right? So if an array is defined with limited space or capacity in an array in the operating system, there is no way that it can be expanded, right? So that limitation is resolved with a dynamic linked list, dynamic array, that is called array list. We discussed array list in half of a class maybe, and then I asked you to do study yourself. And then we discussed linked list, right? Then stack and queue. Those are actually linear data structure. Linear means one by one, like serial. Okay, there is only one line. Okay, one of the advantages of linked list over an array is that in an array you can contain or hold only one kind of data, right? If you declare an integer array, you have to hold only integer value. Okay, you cannot mix up. Although you can create an array of an object, that is different thing. But we discussed that in a linked list we can create a node with an object actually, with an object that holds multiple type elements, integer type as well as string type as well as float type, combined type, right? So linked list, stacks and queue, those are the important things. Actually those, and then after that it comes graph and trees, and then graph and trees. There are other two important data structures, graph and trees. Just in this class we will give you just brief introduction about these data structures. Data structure means how you structure your data, how you put your data. For instance, if you have a book, if you have a lot of books, 100 books or 1,000 books in your personal library, how do we keep those books in your library? I mean, in your shelf. Do you put them randomly, or do you stack them one after another, or do you just throw? Okay, so if you throw one after another randomly, so it will be difficult for you to find or search one, right? But if you have a shelf or bookshelf, some bookshelves, then if you put them randomly, but they're still organized, other than throwing on the floor. But if you organize your shelf nicely, like in ascending order or descending order, alphabetical order of your books or author name, then it will be easy for you to find out a book quickly. So that is the kind of structure. How do you organize your shelf or your personal stuffs at your home, right? Some people are very organized. They keep their shelf and then tables nice and organized, and some people they keep unorganized, right? So actually these content are just give you some heads up about the data structure class. There is an algorithm class. Actually data structure is the most important class, okay, for computer science and software engineering. Hopefully you will take that at your senior level. One thing is that every professor says that his class is most important, right? Every professor, you see that, will be claiming that, okay, his class is most important, his class is most important, so give attention to his class. But I did not claim that my class is most important. But one thing I claim that this is your gateway. If you want to do your major in computer science or software engineering or IT, then this is a gateway. So now you assess yourself whether it is an important or not. Hopefully you understood so far, right? Okay. So linked list, stack, and QE are the most three important topic in your data structure. You will learn more in depth, but so hopefully I gave you some introductory concept how to implement a linked list. That will be easier for you if you take data structure class. I think you got partial already done. So yeah, also you will get at least one questions from linked list, at least one questions from stack, at least one questions from QE. Okay, just start reviewing your what is that called, test 1, test 2, and test 3. We will put some study guide by the end of this week. Sorry? Yes. Yes. But your final will be cumulative, right? So all from your test 1 to up to today's class or this week class. Okay. So we are discussing non-linear data structure. Why it is called non-linear? Is something is kind of unstructured. It's structured but kind of unstructured. But as we discuss, an array or a linked list or a stack or QE, those go in a straight line. Data goes one after another on a straight line. Remember that? Think about an array. How do we define an array or when we have an array, when you declare an array, what is that coming up? You remember that when you declare an array, that array was like this: some nodes or some So elements for array, linked list and stacks and queue for all those kinds. So data are on in a line, single line. Somehow one after another, one after another. Okay. But we will discuss other types of other data types, data structure, that is trees and graph. Okay, that is not on a single line. So most of you are familiar with trees and branches. So a tree is like how a tree is organized. A natural tree. It has a root and then branches, 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 branches. Right? Okay. And there is another data structure that is called graph. Graph is like in real life we have map in our route. When we travel from one place to another place, we, the Google and other organization has developed maps, right? So maps are kind of graphs. They are organized in internal structure. They structure as graphs. But if each of the places or house or offices or places are, each of these places is a node. For instance, if this is the number 5 is an office or a house, how can you go from this house number 5 while you are waiting at place 3? So you can go this way. You may go directly if there is a way, there is a path from 3 to 5. But there is no path from 3 to 5 directly. Then you can go from 3 to 2, then 2 to 5, or 3 to 4 to 5, or even 3 to 2 to 1 to 5. Okay, this call is traveling or traversing. Okay, this is a kind of graph. So a graph, you see that a graph can have multiple references or multiple ways to traverse. For instance, if I want to traverse from 3 to 5, I can go through 3 to 4 to 5, or I can go through 3 to 2 to 4, 5, or I can go from 3 to 2 to 1 to 5. Maybe there will be a shortest distance. Or sometimes when we use GPS, right? Sometimes we say avoid freeway, right? If someone is not comfortable driving in a freeway, then he set up his GPS like this way: avoid freeway. So then the GPS will not enter him to the freeway, but bypass the freeway. Maybe that will take a longer way. For instance, if my path from 2 to 5 is a freeway, if I am not comfortable to drive through freeway, then maybe I can go from 2.2 to 1. If this is a local way, then 1 to 5. Then here we see that the path from 2 to 5 is called the shortest distance. Here. But although the path from 2 to 1 to 5 is not the shortest distance, but maybe it is useful or comfortable to me. Yes. Hmm? I don't understand. Yes. Yes. Okay, there are two kinds of graphs. So bidirectional or unidirectional. So when you know the implementation, you will learn more this. But it is a good question in your mind. So in this course we are not going to discuss in depth. So if we discuss in depth, what you will study in your data structure class? You will study this in your data structure class. But that is a good question in your mind. So here you see that next one, this is a unidirectional graph. One way. The roads are one way. But there are some, if you see the both arrow in both sides, then you understand that there will be a bidirectional graph. So graph can be a unidirectional or bidirectional. Good question. You will understand that, or you will learn this in your data structure class, where you will really will be programming for graph implementation. Okay, so the next one is a tree or trees. Okay, a tree is a kind natural tree. There is one root. It's called root, or what is that called? Huh? Trunk. Okay, and that has many branches. So that is called one single parent, and actually zero or more children. If there is no child, then zero child. And then here in trees, that children are called node. Yeah, actually leaf. Okay, actually children, a node with no children is called a leaf, and the topmost node is called the root. Okay. And I wish I could draw a tree over here. I don't know, I cannot draw it. Why? Okay, so if it is a tree, for instance, these are roots and these are roots, a tree can have multiple branches. A tree can have multiple branches, or then sub branches. Okay. This is a like regular tree. Okay, but this is called in array tree. The tree will have multiple branches in natural. That is very natural, and in a regular tree have multiple branches, right? But think about a tree that is called a binary tree that has only two branches, and each sub branch has again another two sub branches. Like if a tree is like this is a tree, this is a tree, and it will have only two branches. Every time it will have only two branches, and for this branch it will have another two sub branches, only two, not more than two, and for this branch it will have only other two branches like this. Okay, that is called a binary tree. Only it has two children, or two actually sides. So now we are familiar with this kind of tree, right? We are familiar with this kind of tree. Now think about situation. How if I put this tree upside down? If I put, so this is my root, right? For a tree, this is my root, right? Or top, where think about a top where the tree is planted. So this is my top. So here the tree is planted. Now if I can put this tree upside down, then what will happen? This will be my root. So then if I can put my tree as upside down, I have a picture. So then this will be like this. So this is my root. Think about that. Here is my top, where the tree is planted, right? Then this tree has two branches, the left branch and right branch. This left branch has again another two branches, this sub branch and this sub branch, and this left branch has again other two branches, this sub branch or this sub branch, and each of these. So at the end, when there is no branch, that we call this is as a leaf. At all the way end, okay, if there is no more branch, that is called a leaf. Okay, so here at this point 2 is actually a leaf. After 2 point, so there is no branch, but 4 has 2 branches, right? 6 and 2 and 6. So this is a binary tree. Okay, this is a tree. So we will discuss a tree. So we started with trees. We saw trees. Then we are talking about n array trees. That means if there are more than or 0 or more or any number of branches, then let us narrow it down with binary search tree. Okay, so let us focus on this definition. A binary search tree allows for fast insertion and removal of element. We will discuss how it is easy. What is that? Okay. So here is the point actually. A binary tree consists of 2 nodes, each of which has 2 child nodes again. Okay. And then all nodes in a binary search tree fulfill the following 3 properties. Okay. Descendants to the left have smaller data values than the node data value. Then actually there is a mistake over here. Then the right node data value, descending to the right value, larger value than the left node data value. Okay, so there is actually missing 2 words. Just I have added here. Let me highlight it so that you can understand. Okay. Okay, so these are actually focused here. Then the right. Okay. So we need to understand these 2 points in order to understand a binary search tree. A tree will be called a binary search tree if its left child left node contains a value less than its right node. So here you see 15 is okay, but here 8 is less than 25, right? Then it is a binary. It's up to this is binary search tree. Okay, a tree will be called a binary search tree if it has these following properties. So I am describing these following properties here with an example. All of the left node values will be less than its corresponding right node values. The concept is that your elder brother cannot be younger than you. Your elder brother cannot be younger than you, right? Okay, so the left node value will always be less than your right values. And again here 8 has 2 other nodes, 4 and 10. This 4 is less than 10. You see that all of these values maintain this criteria. and vice versa. If you understand one side, if you understand one of these, then you understand the other type. Other condition is just reverse. Other condition is that your right side value will be always greater than your left side value. So this right side value is always greater than your left side value, then left side value, then left side value. You see that? For everywhere, this tree is maintaining these two conditions. So always right node value is greater than the left node values. So here 30 is greater than 20, 20 is greater than 10, 10 is greater than 4. And here 36 is greater than 28, is greater than 24, 24 is greater than 17, is greater than 17 is greater than 12, and so on, right? So this is a binary search. Yes, you have a question?
How are those numbers related to 15? I mean, why is 15 group? Or is it just, like, is there any relation to these numbers?
Yeah, we will discuss this.
Is it just like a random group of numbers?
We will, yeah, we will go through this.
Okay.
So this is an example of a binary search tree. So the main condition has two conditions. Actually, the descendants on the left value, smaller data, descendant to the left have smaller data values than the right node data values. Right node data value, okay? And the descendants to the right have larger values than the left node data values. Okay, so now understand these two conditions? Okay. Everywhere the right side will be larger value than the left side. Right side will be larger value than the left side. Okay. And here, this is node, for instance, I am showing this example with integer value. The node contains integer value. But a node can contain any kind of value. A node, we saw that a node can contain an integer value or string value or combination of both. A node can be an object. So that can be this is a BST, can be BST of name, people name, student name. Okay. Or this node can contain both name and maybe age, but be careful that in order to implement a binary search tree with both name and like age will be difficult, because we have to maintain both name and age will be less than on left node from the right node values. But we will discuss with a simple binary search tree that is easy to implement and understand the concept. Sorry, maybe I will not be able to cover the review. The time is going fast. Okay, so now everybody understand what is called a binary search tree? Okay, this is the definition of binary search tree that has these two conditions. These two conditions. Okay, a binary search tree is a kind of also called a balanced tree. Balance means each node has approximately same as many descendants on the left side and also on the right side. You see the balance is that? So this is the left branch. It has how many descendants? The right side has the same kind of. Maybe so. Sometimes it is called fully balanced if the left descendants have as many numbers in the right descendant, but sometimes maybe right descendant or left descendant can have a few more or less elements. Yes. Sorry? No, a binary search tree you cannot have two or same numbers. That is another good point in your mind. that I was going to tell it here. You cannot have 2 points. Yes. So, so whatever you consider as a root or a node, main node, the right value will be greater than that node, and left value will be less than. That is the condition. So here for 15, right side value is 25. It could be 21, 22, 24. No, no. So that condition does not match, right? Right value will be always greater than left value. Yes.
So this the list of the numbers, right? How are the numbers assigned to come on the tree?
Yeah, that is the good question. We will learn that. Maybe today I cannot complete this. So in the next class we will, good question, we will discuss this. How do we implement a binary search tree?
Does the root node determine how many descendants it can have? Like,
Hmm?
so if the root node is 15, does that mean it can only have 15 descendants?
No, no, no. 15 is a value.
Oh, okay. That's fine.
No, node contains value.
Uh,
Okay. In my GitHub is John, give me a second, please. In my GitHub account, I should have a program. It is called implement BST. BST. Okay. Implement BST. This is a program, complete program. It has how to implement BST. So hopefully in our next class we will discuss this implementation. Okay, but if you have time, then if you can go ahead, then you can clone this project and you can start writing this. Okay, time is going fast. Let me finish this. Okay, give full attention, okay? For the next 5-6 minutes, give full attention. We will understand tree BST, actually BST traversal, not tree, binary search tree traversal. Okay. Okay, so let me make the full screen. Okay, binary search tree traversal. There are 3 kinds of traversal. 3 different kinds of traversal, okay? One is called pre-order traversal, another is called in-order traversal, another is called post-order traversal. Okay, so this is a tree, and the result of in-order traversal is this way, and pre-order traversal is this way, and post-order traversal is this. Okay, for a long time I did not see that. Let us verify whether these order are correct or not. If you get a question like this, if you do single mistake, so this order, then you will lose point. Okay, but if you understand the concept clearly, you will not do many mistakes. But if you do not understand the concept, then definitely you will do mistake, because there are a lot of combinations, right? You cannot put this randomly. The numbers are not put randomly. There is a technique. So if you give attention, then I will tell you the technique. Yes. First is called in-order traversal. You see that if you do in-order traversal, then how the values will be displayed. I'm getting 2, 4, 6, then 8, then 9, then 10, then 12. Did you notice any trick? Yes.
It goes from the left to the right, and then the one on top, and then if there's anything on top.
Okay, anyone has any clue? I'm telling you again. I'm getting 2, 4, 6, then 8, okay, then I'm not going 10, then I'm going to 9, then I'm going 10, and then I'm going to 12. Let me tell you again one more time. I'm going to 2, and then 4. Let me see if I can annotate it. I'm going to 2 first, then 4, then 6, then I'm jumping to 8, then I'm jumping to 9, then 10, and then 12. Anyone got any clue? So this is called in-order traversal. Do not see these two lines. Okay, do not see these two lines, pre-order or post-order. Give attention to here only in order. Okay, anyone got any clue? Yes. Okay, I'm telling you technique. Then I will hide this line and I will ask everybody to write it down, and then we will compare our results. Okay, everybody please open your paper and pencil. Okay, let us do a practice. Okay, meanwhile I am telling you the technique. The technique is very simple. If you understand this, remember this, then it is very simple. And then, okay, the technique is that when you say in order, then your node or root, here what is root? Okay, 15 is the root of the entire tree. Okay, and 8 is the root of this left branch, and 4 is the root of this left branch, right? Okay, and 10 is the root of this branch, right? 10 is the root of this branch, and 4 is the root of this branch, and 8 is the root of this entire branch, right? And similarly again, 20 is the root of this branch, and 30 is the root of this branch, and 25 is the root of this branch, and 15 is and 15 is the root of the entire tree, right? So when you see in order, then your root will be in between your left branch and right branch. Okay, so here my in order, that means here my root is 4, right? In order, I will start from all the way in left side. Okay, then when I start here, then in order, that means my root will be in between my left and right node. So then I will start from 2, 4, then 6. You see, 2, 4, and 6. I don't need to see over there. Then when I'm done this branch, I will move up to the root. Then root is 8, right? Then I got 2, 4, 6, 8. Then when I am done, then my root, this is root inside, then I will come all the way this branch, and then I will start from here. Then 9, then 10, then 12. Then after all the way, I will jump to 15. 15 is my, because I'm done when I'm done with this branch. When I'm done with this branch, so let us do this branch first. So 2, 4, 6. Everyone understand? 2, 4, 6, then 8. Okay? Then 9, 10, 12, then 15. Then all the way it will come 17. 17, 20, 24, then 25, then it will come all the way end 28, 30, 36. Okay. So okay, let us everybody please open your paper and pencil and let us try together. If you understand one of these, then hopefully you understand all. Okay, let us start. So I want to do in order traversal. In order, the technique is your node will be in between. Oh, I'm sorry, it's going. Actually, I wanted to, let me do it here. Okay, let me do in order traversal. So if I do in order traversal, then I will have 2, then 4, my node is 4, then let us use comma, okay, 2, 4, can I use this, 2, 4, then 6, right, okay, then 8, then what, yes, then it will come 9, then 10, then 12, then, yes, then 15, then what, okay, 17, then 20, then 24, then 25, yes, 25, then 28, then 30, 38 and 36, okay, then 38 and 36. Okay, who did not understand this?
Not necessarily.
Who did not understand this? Do you understand?
Yeah.
Last 25, okay, 28, because when I am on this root branch, my root, okay, this 25 is the root of this branch and this branch. So when I finish this branch, then I will jump to 25, and then when I come to this branch, I will go all the way end 28. So after 25, I'll go to 28, then 38, then 36. You understand? Anyone? Okay, so for in order, you will put your nodes. Now let us circle our inner node, middle node. Okay, so here is 4, right? 4, then what? 8, then 15, then sorry, 25, then here in this 20, right? Then 20, or 10, yes, 10 is also another. 10 is also 10, this is then 20, and then 30th, 25 also, right? 25, and then 30th. These are the root, and other are called leaf, like 2, 6, 9, 12, 13, 17, 24, 28, and 36. These are leaf. Okay, once you understand this, other two are very easy. Okay, for in-order traversal, give me 1 more minute, please. For in-order traversal, your route will be in middle, and for pre-order, your route will be first. Okay, and post-order, your route will be last. Okay, this is your homework. Before you come in the next class, try to understand this. Okay, and yes,
How would I get a read grade?
yes.
How do I,
Give me one second.
okay.